Hello all my JavaScript friends, this is the Virtual Void aka Mike Smith, and this video will show you how to actually develop the class that will become the deck class. If you like this video, click on the like button below, or if you wish to subscribe to this channel, click on the subscribe button and leave a comment. I'd love to hear from you. Okay, let's get started. Now remember, we did test-driven development. That was done on our last video, and if you watched our last video, then you found out that all our tests failed because we had not created the class itself. So let's just create the complete and total empty class. So actually what I want to do is create a new directory called source. And within our source directory, we'll create the deck class. There. So let's run our test. Let's see what happens. And I will join you as soon as we're done. Okay, we're done. As you can tell, 28 of them failed, 7 of them succeeded. Now, why did they succeed? Well, they probably succeeded because of the way JavaScript works. Not much we can do about that. For instance, one of the tests in the constructor basically says that, hey, did it create a class called deck? Well, even though we have absolutely nothing in our class, it still created a class called deck. So that one actually passed. And a lot of these are pretty much the exact same thing. So let's go ahead and take a look at creating the class itself so we can turn all of these red failing tests into successful tests. All right, let's take a look at the constructor first. Now, as you can tell here, we had 8 tests with the constructor, and 2 of them actually passed. We should not be able to access the cards property at all, which remember, we're checking to see if the cards property is undefined, and of course it's undefined because it's undefined. So that obviously passed, and we should create a deck class, which obviously we create, even if it has absolutely nothing in it, we create a deck class. So I expected those 2 to be true, but now we need to be able to create a deck class with 0 cards, or with 1 card, array, and so on and so forth. So let's take a look at the constructor and how it's going to look. Okay, so we have our constructor here, and a couple of things we want to point out is that, first of all, we're going to accept some arguments. If we go back to our, where is it? Let's go back to our integration constructor spec. We're basically going to want to say a new deck with passing an object which has an ID and cards, and that is situated right here. So we're taking out the cards and the ID. Now we're giving it a default of a blank object, because if we don't have a blank object there, then as soon as we do something like this little deconstructor here, it's going to give us an error. So we don't want that. So by default, we're going to have it as a object here. And of course, we're going to give default values for both cards and ID. This UUID v4 is from a library called UUID, which, as you can tell, has not been installed yet. So let's go ahead and install that real quick while we're here. npm install save UUID. And that finishes up the UUID. Let's now go back to our constructor errors, and let's start making sure we can take care of each one of these. Okay, so the first we can do is we've got a routine here called validate cards. Now this is a private method, and again, a private method in JavaScript, and actually this holds true for a lot of languages, is basically a method or a variable, because we have some private variables up here too. A method or a variable that is only accessible within the scope of this particular class. It is not accessible by an instance of this class, but only by this particular scope of this class on its own. And it's a very big difference here. So if an outside application instantiates this class, validate cards, this method here, and validate card and cards and ID is not accessible. And I'm going to tell you why I did that here in just a minute. Okay, so we're going to call validate cards, and validate cards will first of all throw us an error, a type error, if cards argument is not an array. And that should throw exception if card is not an array. So that should fix that particular one. All right, then we're going to check every single card and check it against validate card. And what does validate card do? Validate card basically will throw an exception if a card is not a instance of card. And it's going, since it's going to go through each and every single one of the cards here, the minute it throws an error, it's just going to stop this process right here, and everything just kind of gets shut down. That should allow us to fix this, or to satisfy this particular message right here. Should throw exception if cards does not contain an instance of cards. So that takes care of two of the errors there. Then we're going to save ID, and we're going to save cards. And we're saving them as private variables. And the reason we're doing that is that when you have a public variable and you create an instance, that variable is available to that instance, but everybody who is accessing that particular instance. So we lose control over how that particular variable is worked upon. So by having it as a private variable, nobody can access ID, nobody can access cards unless we tell them that they can access cards. Unless we tell them that they can actually access the cards or access the ID or anything in there. I personally like to always do private variables and private methods so that I can completely control everything that there is concerning that particular variable. Okay, so the constructors, oops, actually we want to go back here. So we should be able to create a deck with 0 cards. We should be able to create a deck with 1 card. That should automatically be taken care of also by our code already, because this will basically, since we're defaulting here to a blank array, that's going to satisfy the 0 cards. And if we have anything within the array and it gets past this point, then we know that cards is going to have one or more card instances within it. So that should satisfy these two. So now we got these first 4. What about these last 2 here? Should create a string ID as default, and we have that because here's the default ID equals UUID 4. And finally, should create a specified ID. So we save that as ID. But here's a problem. Now remember I said private variables are not accessible by an instance of this particular class, but only within the code or the scope of this class. So how can we test to find out if our ID has the ID that we want in there? If we do that, we have to be able to make that ID available, and that is with what we call a getter function. And so a getter function will basically now say, this is a getter function right here. This basically says now is I will expose a variable called ID that will return this. So anytime any application accesses the property of an instance, the property ID of any instance, I want to return this.id. So again, I'm giving them access now to the #ID, the private variable ID, but only if they have a .id. And that allows me to control when and if they get the value. And this means that we don't actually have to declare values here to be able to do a getter function. We can do a getter function on anything, and we can return anything we want, as we'll see here in just a second. So if we go to the constructor, so that should satisfy all of these, but let's just go to the constructor spec real quick and see what we have, okay? Notice that the only way to be able to figure out if we have 0 cards or 1 card is if we have a property called card count. Now, card count is not listed up here as a private variable, so let's create a getter function for card count. And there we are. Now we have a public variable called card count that will allow me to only return the length of the card. So now card count will tell me how many cards are in this cards. Now notice I have absolutely 0 access to cards at this particular point in time. So that should satisfy all of this. There's my card counts. There's my 2 exceptions. We should not be able to access cards in the property at all, deck.cards. Remember, that was the one that still came out to be true, and it's still true in this case because if you notice, I have no property here called cards that is a publicly accessible property. If I had a getter function for cards, then it would be a publicly accessible property and they'll be able to get to it. But because I have no getter function, cards is completely internal to me and not to anybody else. So this little squiggly line here saying unresolved variable cards is correct. That's what we want. And the rest of that looks okay too. So if we were to run our test at this point, all of the constructors should be okay, and I'll see you as soon as it's done. Okay, and we're done, and sure enough, we have no more failings in the constructor. In fact, actually take a look at this too. We even fixed up the card count and the ID spec. If we take a look at those 2 properties, the only thing we checked for is to make sure we could not change the card count and that we could not change the ID. And sure enough, that's exactly what happened. We can't change those two because we only had getter functions, not setter functions. A setter function is what you define to be able to say, what do I want to do when I want to change a variable? If we don't have a setter function, we can't change the variable. So therefore, so not only do we take care of the constructor, but we also took care of the card count and the ID too. All right, so now let's take a look at these 5 methods here, the findCard and the forGet. Now the forGets are pretty much run the exact same type of code, so this is going to be very easy to do. In the findCard, remember, it will be able to find a value or find an element within the index, but will return an index number instead of actually returning a deck, which is what comparison, rank, suit, and value would do. So let's take a look at all of those. Let's clear off our screen a little bit here. Okay, we've got our code on the screen here. Let's take a look and see what it does. So let's take a look at the get rank, get suit, and get value first. Now the key here is that get rank, get suit, and get value is going to each of them are going to return a deck of cards, and the deck of cards will contain all the cards that match a certain rank, a certain suit, or a certain value. And within the methods here, let's just do get rank as a sample one here. Within the get rank, we should be able to return a deck of cards based upon the rank, and that should return us a deck with a rank, or we should return an empty deck if the rank does not match. So what we're going to be able to do here, since both rank, suit, and value all run the exact same comparison routines with the exception of what method it runs on the card, we've written ourselves a private method here called compare that's again only accessible to us, that we can just run both. We can run all 3 get value, get suit, and get rank against. So let's just take a look at one of them. So each one of them is going to call compare, and it's going to pass a function name, because the function name within the card is rank, or is suit, or is value. So it's going to pass the function name and the value we're going to check for. That's the same thing with rank, suit, and value. The compare method says, first of all, it takes an operator and then the property value. And basically all we do here is that we, against the private variable cards, because remember, we can access the private variable cards within our scope, we just can't access it within on the instance itself. We're going to check the deck card operator, and this is a way that we can call a function within the within a class. We could always say, of course, as we do here, just for sake of example here, our variable name dot whatever. That's one way we'd call a class. In fact, take a look at the very top here. We have a card compare and a card.is. Well, we can also call the function if we put it in square brackets. And so that way we can actually pass a variable function to it. So my operator variable here contains the function name, and it contains either is rank, is suit, or is value. So we're calling deckcard.isRank, .cardIsSuit, or .cardIsValue, and then we're passing it the property value. That gets us to retrieve cards. What we should then we'll return the retrieved cards is going to return an array of cards, and that array of cards is possible because of the filter command, because the filter method on an array, because #cards is an array. That filter method will always return an array. If everything matches here, if we're doing the deck card is rank, is suit, or is value to the property value, if that returns true, because that's already going to return a false. If it returns true, then that element gets added to a new array that's created by filter. If it's not true, then nothing gets added. So at the end of the day, filter is either going to return an empty array or it's going to return an array full of cards. So all we have to do is return a new deck, and within that new deck, we don't even care about an ID or anything like that. Within the new deck, we pass a new deck of cards. That's it. So what gets returned from get value, get suit, and get rank is a deck of cards. And that's it. There's nothing really else to it. The filter is going to take care of our either 0 or not 0 number of elements. This is going to take care of the deck. So that should take care of, if we go to the errors, that should take care of everything that we see something like this. Right now it's saying not a function. Well, now we got a function. So hopefully everything will pass once we run the routines here. So that takes care of get value, get suit, and get rank. How about get comparison? Well, get comparison is a little bit different, because the idea here with get comparison is that we're going to want to, first of all, validate that we're actually passing a card. It's very important to know that we're passing an actual card. So we're going to validate the card, and all we're checking for on the validate card is whether we have an instance. If the card is not if it's not an instance of card, then we throw it out. And then we're going to just do the same compare compilation here, except that we're going to run the compare method. And again, compare method is something that is not inherent on the card, but it's something that the application will create. So that should take care of get comparison. Now findCard is just a little bit different. findCard returns an index number. And let's bring up the findCard specifications here. So findCard's got a lot more to it here. We should be able to find the card. We should find the card. We should not find the card. We should throw the exception if the card is, if its argument is not a card. We should find a card using compare and should not find the card using compare. So we got to take care of all of those. So the first thing we want to do is we want to validate the card. That will take care of our exception. Let's kill this one right here. That should take care of this exception right there. All right. Then we're going to get the compare method from our find options. Find options being our second argument, which defaults to an empty object because sometimes we're not going to pass find options. If we take a look at our code here, we're using deck.findCard with just a single option. Here we're using deck.findCard with two arguments. I said options, sorry, with two arguments, with the second argument being that compare. So we're going to default our second argument to the blank object, and we're also going to make sure compare is equal to false as the default. So then all we have to do is we're going to, since our cards is an array, we're just going to use the find index on the card, and we're just going to do something very, very simple here. If we're using the compare method, which is basically setting compare equals to true, if we're using the compare method, then we return card.compare to our deck card. Otherwise, we return card.is to the deck card. And it will go through this index until it finds the card. Once it finds the card, it returns the index number. If it doesn't find the card, it returns a -1. That should then take care of both of our routines here, where we're going to pass -1 if something is not there, or we're going to pass an index number. So that's all we really need to do on the find. That should take care of all 5 of our find tests. And we should also take care of all of our tests here. And again, everything is basically using that compare. That doesn't really mean anything. So anyway, so let's go ahead and go into our test. And let's run our test, and I'll see you on the other side. Okay, we're done. And oh, this is looking good. Our find spec now works. Our get comparison works. Our get rank, get suit, and get value all now work. And our constructor is still working, as is card count and ID. So we're getting close. We just have 8 specs left that are failing, and our deck will be complete. All right, as you can tell, we've got 4 left. Let's just take them, they're not quite in order. I want to do them in special order here. Let's take a look at our add first. Now, our add spec is very, very simple. We just got really 2 different specifications to take care of here. We should be able to add a new card and expect it to actually add the card to the deck, and we should be able to throw an exception if we don't add an actual card. So I'm trying to add a string here, so that will not work. So let's go ahead and let's throw some code in here. And there we go. That's pretty much it. So the validate card is something we've done plenty of times before. We've got this down here. And this basically allows us to validate that whatever we passed is actually a card. That will take care of the exception here. And then we're going to push the cards. So that should take care of this. How do we know? Well, we have card count here, and we already know that we got card count, which returns the length of the cards. So that actually should be it. Let's run our test. And I will see you on the other side. Okay, we are done here, and yep, indeed, our add spec is now passing its 2 tests, and we are still completing all the rest of the other tests. So now we're just down to our deal, our remove, and our shuffle. So let's take care of remove next. All right, let's go ahead and do the remove. So the first thing we want to take a look at is what our specifications look like here. Now, actually, as you can tell, we got a little bit more here because there's more that we want to do with the remove. If you kind of think about it, I want to kind of anticipate when I would need to be able to remove. And For instance, when we're dealing a card, we're removing a card from a deck that's going to remove the top card. So I want some sort of routine to be able to remove the top card no matter what. If you're playing a game of fish, you say you got any threes, you got, you have a three of spades or something like that. If you're playing super fish, then be able to remove a card based upon whether it is a specific card or not. And then again, if you are working with, a magician, he says, he spreads out the deck on the table and says, hey, take any card, no matter what, you're just going to take a random card from the deck. You're basically taking a card based upon the index number. So those are the three different routines we're going to be able to use with the remove. And I've got them listed up here at the very top here. We can specify a card, which will remove a specific card. We can specify an index, which will remove an index number. And this will be an index just like you have an array, where -1 means there's nothing there, and 0 to the length -1 is the index number of the card. And remove with absolutely no arguments, which will allow us to be able to remove, which will automatically default remove the top card. And notice we have another one here, and I forgot to mention this, is that when we're doing the card argument here, we need to be able to compare it both with the normal compare method, and that's using suit, rank, and value, or using the compare method that is available within each of the cards. So just like we did with the find card option, find card that we did earlier, we're going to have a second argument here with a comparison. Be able to tell whether we're going to use the compare method or not. So here are ifs. We should remove the card based upon the card argument, move it based upon the index, based upon the top card, based upon the action. And let's see, should throw an exception if the argument is not specified or not a card, and we should return null if the card is not removed. So if nothing gets removed, then we should return null. So let's take a look at the code for that. And here we are with the code. Now, I pre-program a lot of this and kind of just test to make sure everything is okay before I do my videos. And so this was the routines that I came up with, because what I discovered as I was working on all of this, that everything really comes down to removing a particular index number. If I have a card, I find that card, the find option, the find card option will return the index of that card within the deck. So there's an index number. If I'd say remove from an index number, of course remove the index number. If I remove from the very top, then that removes index number 0. So I realized doing that I can shorten up my remove to make it a lot easier to understand. So if the card is undefined, which means I've specified absolutely nothing for the card, which means by default I've actually also specified absolutely nothing for the remove options, then I'm going to call a internal private method called return blank. If the type of card is the number, that means it's going to be the index version of it, so I'm going to call a private one called remove index. And finally, if it is an instance of card, then I'm going to return a private method called remove card. Private method called remove card, passing the remove options that we have here. And then I will go ahead and validate the card, because I know it's not going to match at this point either undefined, number, or card, so it has to be an error, so the validation is going to find it very, very quickly. Alrighty, so we don't have any of those routines, so let's go ahead and pop them in there one at a time. Let's first start with remove blank. And here is remove blank. Now remember, remove blank basically says we're going to take the top card. What's the index number of top card? 0. So all we're going to do is come in and call remove index 0. Ta-da! Could not get any easier than that. So we've got the remove blank. What about the, actually I'm going to go to, for funsies here, I'm going to go to remove card next. So let's bring up that code. And you'll see why here in just a second, why I've decided to do remove card next. So here's remove card. And this again is if we specify, let's go back to the top here. If we specify the card, we're going to remove the card. So here's our remove card. I'm doing the card and remove card options. I'm just going to call found card. And what is find card going to return? Find card is going to return to us the index number of that card within the deck, either from 0 to the length of the deck -1 if it can be found, or -1 if it could not be found. So now that I have an index number of the card, what am I going to call? I'm going to call remove index. So you see, this is the reason I split everything up like I did up here, is that it's very easy to understand saying, okay, I'm going to remove it if it's blank, or remove it if it's an index, and remove it if it's a card. And by splitting it all up like that, then I can have these two routines also called remove index, because everything's eventually going to gel down into an index. So what is the last one we need to bring in? That is our remove index. Yay! So we remove the index. And what we're going to do here is we're going to ask it, hey, what card do you want to remove? I'm going to truncate index. So I want to basically make sure it is an integer number. I kind of just, if you pass it for some strange reason, I want card number 2.629, that's just not going to work. So I truncate it down to index. If it is less than 0 or is greater than or equal to card count, return null, which satisfied the test that, hey, if the card is out of range, return null. Otherwise, it's going to splice it out of the array, because remember, splice basically removes cards from array. What removes cards from the array? What card am I going to remove? That's the card. How am I going to remove 1? The key here is, and this is always what gets me, is that I know I'm removing 1, but JavaScript doesn't. So if I'm removing things from an array and I can remove more than 1, it's going to always return me an array. So I need to always pass the 0th element. And that way I only pass just 1 card. And this will satisfy the remove equation, so to where, let's go back to our spec here, to where I will always return a card if I remove a card. Like for instance, let's just take this one here. Remove card, deck.remove. Make sure to, then we do expect that the remove card is an actual card. Very, very simple there. So that should take care of everything. The remove blank, remove index, and remove card. So are we sure that takes care of everything? Well, the only way to find out is to run the test. Hey, so I'll see you on the other side. And we're back, and where is our remove? There it is, our remove spec now completes its 6 tests. We just have 2 left. That would be deal and shuffle. So, hey, let's go ahead and get to those next. Okay, now let's deal with the deal method. So let's take a look at our specifications first, and we should be able to deal 1 card off the top of the deck, and we should be able to throw an exception if the deck argument is invalid. And there's my invalid deck argument. So let's throw the code up there. And here's the code. I do also have a validate deck routine here. This is going to throw the exception if the toDeck is not exactly a deck. So we're going to need to get in here, and we're going to need to throw that code inside there. And there it is. Very simple. Hey, if it's not an instance of deck, we just throw the error. So that should take care of everything. Let's go back up to deal. So the validate deck will take care of the exception. And the rest of this should actually remove the card, which should take care of this part. So the only thing left to do now is to run the test, and I will see you on the other side. Okay, so we're done, and yes, indeedy, our deal spec has completed. So we've got 1 left, and that's the shuffle. So let's take a look at the shuffle. Shuffle should be fairly easy to do. Let's take a look at our spec. Oh, we just have 1 spec. We should shuffle the cards. So basically, this is a very wicked little test here, because obviously all I'm doing here is the only way I can be able to know if it's actually a shuffle of the cards or not is to basically take an unshuffled deck of cards, which is what this deck shuffle cards is all about. And I will compare it 1 by 1 with what came back from the card itself. Excuse me, from the shuffle deck itself. If they all came up exactly the same, then the cards were not shuffled. If at least 1 got changed, then it got shuffled. It's a horrible way of doing it, but hey, I really couldn't think of another good way of getting that done. So let's go to our deck. Let's pop in the shuffle code. So it's very simple and very straightforward. Ta-da! Basically, I take the random card, I replace it with the very last card, and then I just subtract that index. So I'm only taking a random card from the whole thing at the very beginning, and then from the whole thing -1 at the very beginning, then -2, -3, -4, all the way until the very end, and we replace it basically with itself on the very end. So that should shuffle the deck. Very easy, very, very, very simple. Let's run the test. I'll see you on the other side. Okay, our specifications for shuffle has now passed, which means look at that. Yes, they've all passed. And since they've all passed, that means we're done, right? Well, no, not quite. What you really need to do, and I'm not going to go through it with this particular one because it's very simple, is we need to go through and refactor all this stuff to make sure that we've got everything correct. One refactoring I would love to be able to do is, and I may run a video on this a little bit later on, is when I deal a card, I want to, or excuse me, when I add a card, excuse me, I was thinking of dealing. When I add a card, I want to actually add the card to the bottom of the deck. Now I know that the push command adds it to the bottom of the deck, but it would really be nice to have the add specification to specifically say, hey, you know, let's add this to the bottom of the deck. Let's ensure that anything that got added to the bottom of the deck. You know, what the heck? Let's go ahead and add it in. Okay, I've added a new test here that we should add the card to the bottom of the deck. So it's a very simple test. I've got my test card here. I got my deck with one card in there. I'm adding a card, and then I'm removing the card from that is the card count -1. So that should remove it from the bottom of the deck. And so if everything is okay, the card that I just got finished removing should be exactly the same as test card. Now, if I was to run this right now, this test, it still will pass. But the idea here is you have a test that fails first, then you fix your code, and then the test passes. So I'm going to force a failure here by going to the deck, and instead of pushing the card, because I know pushing puts elements at the end of the array, I'm going to actually call an unshift. And an unshift will put cards at the very beginning of an array. So with the add spec, and this is the only one I'm worried about here, this still should work because I'm still expecting the card count equal to 1. This still should also work because the exception should be thrown, but this should now not work because I'm expecting the card that I have put into the deck to be on the bottom of the deck and not on the top of the deck. So let's run our test and let's see what happens. And there's a possibility some other tests might fail here, but that's okay. I'm just looking at the add for right now. Just kind of show you what will happen, because the idea here is you want to be able to, if you got more ideas you want to be able to work with, or get any ideas that you have for your class, you want to be able to first create your test, see that it fails, and then fix your code to make sure it works correctly. So I'll see you when it's all finished up. Okay, we're all finished up here, and yep, indeed, the add has failed, which is kind of what, in fact, it's exactly what we expected because we're adding the card to the top of the deck and not the bottom of the deck. And yep, indeed, it's what it told us. Should add the card to the bottom of the deck. Type cards argument must be an array. Actually, I got an incorrect data here. So type card should be an array. So what did I do? Oh, yep, right here. So bad test. But again, that's why you test everything. Because even the test could be bad. So I got a new card there. See, we're adding a card, so we're fine there. We're removing a card there, so we're fine there. So yeah, so that was the problem here, is that line 21 was incorrect. So guess what? We got to run it again. I'll see you on the other side. Okay, now we're all done, and we still got a failing test, which again is what we expected. But let's make sure our test actually worked this time. Oh, I'm recording this on a Friday afternoon after working all week long. I'm still a little bushed here. Okay, so assertion error, expected false to be true. Should add a card to the bottom of the deck, and that's exactly right. We expected false to be true. So if we take a look at our specifications, the expected false to be true. So it said that, hey, that is actually false. So, okay, so now let's add back in push. We should add it to the bottom. And now let's run the test again. And I'll see you on the other side. Okay, we're done. And yep, indeed, the add now works. So again, that's one of the things that when you do the refactoring, you may think of new tests to add. And so what we have done here obviously is added another test that we didn't think about when we first did this test. So now we're confirming that when we do add a card, that we want it to be able to put it always at the bottom of the deck. And now we have proven that. So that actually, according to our test, hey, that completes the class. Hey, if you liked our video, click on the like button below. Click on subscribe to our channel, or leave a comment. I would love to hear from you. And again, thank you so very much for watching. This is the Virtuoid, aka Mike Smith, and we'll catch you later.